morning, everyone, parents, teachers, all lovers of knowledge, and our great students. On behalf of the management, the crew of Oxygen FM 96.9, situated at the Knowledge Hub, Obafemi Awolowo Way, Okeado, Ibadan. I welcome you all to Chemistry on Air. I am your teacher, SODEEQ, ABIOLA. Welcome back. In today's lesson, I will teach calculations on acid-base titration. So bring your notebook closer and write boldly. Calculations on acid-base titration. So last week, one of my colleagues taught you titration curves and how to choose the right indicator during acid-base titration. So in today we are going to look at calculations on acid-base titration. Also, she taught you applications of acid-base titration. Now, today we are going to look at how we can make use of acid-base titration procedure to calculate the following. Number one, molar concentration of a solution, mass concentration of a solution, molar mass of a compound, water of crystallization, percentage purity and impurity, number of moles. So let me repeat. We are going to look at how we can make use of acid-base procedure to calculate molar concentration of a solution, mass concentration of a solution, molar mass of a compound, water of crystallization, percentage purity and impurity, and number of moles. So first of all, before we look at those calculations, we are going to do a quick revision on mole concepts. So for us to be able to do all the calculation highlighted above, so we need to understand the mole concepts. So what is mole? So when we talk of mole in chemistry, it's like we are talking of currency. So as we know, in Nigeria here we spend naira. So naira is our currency. So and this naira, we can convert it to different currency. So we can convert it to different currency. The same thing goes with mole. So in chemistry, we use mole to quantify substance, and this mole can be converted to other units. So it can be converted to other units. So for those of you that are listening to us, you can also join us live on Facebook, Oxygen 96.9 FM. Also on YouTube, you can watch us live on YouTube as well, Oxygen 96.9 FM Ibadan. So now, for those of you that are live on Facebook, so there is one simulation there, so which explain how mole concept is related to molar concentration. So as we know that the first calculation we have there is the molar concentration. So on the screen you can see, so we have particles. So in a restricted area, which is the volume in a liquid. So as the concentration increases, so as the number of particles increases, we can see that the concentration also increases, provided that the volume is fixed. So in acid-base titration, so we have what we call molar concentration. So when we talk of molar concentration, So that means we are trying to talk of the number of mole in a fixed volume. So for concentration, we use 1 dn cube, which is also 1000 centimeter cube. So now let's look at the relationship between mole and other quantities in chemistry. Like, as we can see, mole is also equivalent to what we call molar mass. So when we say molar mass, so that means the mass in 1 mole of a substance. For example, now sodium chloride, which is NaCl, the common salt we use at home. So the atomic mass of sodium is 23, while that of chlorine is 35.5. So that of chlorine is 35.5. So if we do the calculation together, whatever we get, that is our molar mass. That means the mass in 1 mole of sodium chloride. Also, 1 mole is also equivalent to what we call Faraday. So it also has relationship with Faraday. Also in gas law, 1 mole also has relationship with what we call molar volume of gases, which is 22.4 dn cube at STP. So also 1 mole is also equivalent to what we call Avogadro's number. So this shows that this mole is very, very important. It's also a relationship with what we call enthalpy change, entropy change, change in free energy, and so on and so forth. So that is just that about the mole. So welcome back. For those of you that you are just joining us, so don't forget that you can join us live on Facebook, Oxygen FM 96.9, and we are also live on YouTube. Now, let's start with the first question. Question 1. A is 0.200 mole per dn cube of HCl. C is a solution containing 14.3 gram of Na2CO3 dot XH2O in 500 cm cube of solution. Now, the procedure, because this question is a real WAEC practical question, put A into the burette and titrate it against 20.0 cm cube or 25.0 cm cube portions of C using methyl orange as indicator. Repeat the titration to obtain consistent titer values. Tabulate your results and calculate the average volume of acid use. The equation of the reaction is Na2CO3.XH2O plus 2HCl gives 2NaCl plus CO2 plus open bracket X plus 1 close bracket H2O. Let me repeat the equation. Na2CO3.XH2O plus 2HCl gives 2NaCl plus CO2 plus open bracket X plus 1 close bracket H2O. So that is the equation of the reaction. Now the second procedure, from your result and the information provided, calculate the Roman figure 1 concentration of C in mole per dn cube. Roman figure 2 concentration of C in gram per dn cube. Roman figure 3 molar mass of Na2CO3 dot XH2O. Roman figure 4 the value of X in Na2CO3 dot XH2O. Given that our hydrogen, which is H, equals to 1, carbon equals to 12, oxygen equals to 16, and sodium equals to 23. So now let's start. So in one of our discussion, we have talked about how to take the burette readings and other precautions you have to abide with. So now we are going to start the titration. those of you that are not watching us live, I think you can hear the sound. So the titration is, we are carrying out the titration. We are done with the first, second. Then for the third, we have 23.20 as our titer value. So we are going to start the procedure again. I think you can hear, those of you that you are listening to us. So we are done with the first one. The titer value is 23.80. The second one is on. So the second titration is 23.20 as our final titer value. The volume of acid used rather. The third one, 23.10 as the volume of acid used. So while the fourth one is 23.10. So now that you are done with the titrations, so now let's look for the average volume of acid use, the titer value. So from the values we got, we have 23.80 as the first value, and that's our rough titration. So the second one is 23.20, the third one is 23.10, the fourth is 23.10. So from all the values we have there, we can see that the second titration, third and fourth, they are what? They are concordant, because the difference is what? Is within the range of 0.2 plus or minus 0.20. So we are using those values to look for our titrate for our average titer value. So now, since we have done how to look for the average titer value, from here we got 23.13 cm cube as our average titer value, and that will be our what? Volume of acid used. So now let's start with the first question, where we have to calculate the concentration of C in mole per dm cube. So when we say mole per dm cube, that means the number of mole we have in 1 dm cube. So using formula, we can calculate it by dividing mole divided by volume in dm cube. So, and that is how they derive the what? The unit to be mole per dm cube. Also from the equation of the reaction, we can see that the mole ratio of our base to acid, we have 1 mole of the base reacts with what? With 2 moles of the acid. So that means the mole ratio of the base to acid is 1:2. So we are going to use the formula CAVA over CBVB equals to NA over NB. So where our Ca is the what? Is the concentration of our HCl, our Va is the volume of our HCl, our Cb is the concentration of sodium thiocarbonate 4.XH2O, while our Vb is the volume of sodium thiocarbonate 4.XH2O. So from the procedure, it is stated that using 20 cm cube or 25 cm cube of pipette. So in this question, we are using 25 centimeter cube of what? Of pipette. That means our Vb, volume of base, will be 25 centimeter cube. So from our evaluation, so we are going to make the Cb, which is the concentration of sodium thiazocarbonate 4.xH2O, as our subject of formula. And from the evaluation, so the final answer is 0.0925 mole per dm cube. So also you will see that the answer is in three significant figures, 0.0925. So you need to take note of that. Always put your final answer for the concentration in three significant figure. So now moving on to the second question, which is the concentration of C in gram per dm cube. So we have two methods of doing this. Like from what I've told you at the beginning, that mole can be what? It has relationship with many other quantities like mass. So we can convert mole to mass, Avogadro's number, Faraday, and so on and so forth. So in this second question now, so that means the molar concentration that we have gotten in our question 1, we have to convert it to what? We have to convert it to gram per dm cube. We have to convert from mole per dm cube to gram per dm cube. From the two units, there are two things. There is something that is common to the two. That is the dm cube. So that means both the mole and the mass, they are both in 1000 cm cube of the solution. So the first way to do this is we can use what we call proportion. And this is similar to what we have in mathematics, the word problem in mathematics. So most of the calculations in chemistry that has to do with mole concepts, so for a student to excel in those calculations, you need to have a better knowledge of word problem in mathematics and subjects of formula. So now for this one now, we have 500 cm cube contain 14.3 gram. So that is according to the what? According to the question. Because in the statement given to us about C, which is our base, it says C is a solution containing 4.3 gram of Na2CO3 in 500 cm cube of solution. So that means to prepare the solution of C, 4.3 gram of C is what? Is dissolved in 500 cm cube of solution. So that means we have 500 cm cube of solution C containing 14.3 gram. Now we are dealing with gram per dm cube. So that means they want us to express our volume now in dm cube. And I said 1 dm cube is equivalent to 1000 cm cube. So since 500 cm cube contains 14.3 gram, therefore 1000 cm cube will contain X. So then we cross multiply. So X will multiply 500 cm cube, while 1000 cm cube will multiply 14.3 gram. So we make X as our subject of formula. So we are going to have 14.3 gram times 1000 cm cube over 500 cm cube. So the cm cube will cancel each other. Then our final answer will be 28.6 gram. And since we are to express it in gram per dm cube, that means the mass we have in 1000 cm cube or 1 dm cube of the solution is 28.6 gram. So therefore our mass concentration of C is 28.6 gram per dm cube. So the second method is formula method. So we can also make use of formula. Like I said, that gram per dm cube, from the unit, it means the mass in 1 dm cube. So and we have been given the mass to be what? To be 14.3 gram. And we were given the volume to be 500 cm cube. So to convert 500 cm cube to dm cube, we just divide it by 1000. So that means if we divide 500 cm cube by 1000, we are going to have 0.5 dm cube. Then we are using the formula mass concentration equals to mass over volume in dm cube. So by doing that, we are going to have 14.3 gram over 0.5 dm cube. So our answer will still be 28.6 gram per dm cube. Yes. So the second question there is, we have to look for the molar mass of sodium triisocarbonate 4.xH2O. So the formula we are using for this is molar mass of sodium triisocarbonate 4.xH2O equals to mass concentration over molar concentration, because there is relationship between the three. Molar concentration equals to mass concentration over molar mass. So, and since we are looking for molar mass, if we make molar mass the subject of formula, then we are going to have molar mass of sodium triisocarbonate 4.xH2O equals to mass concentration of Na2CO3.xH2O over molar concentration of Na2CO3.xH2O. Now from the calculated values, our mass concentration of our Na2CO3 is 28.6 gram per dm cube, while the molar concentration is 0.925 times 0.925 mole per dm cube. So the per dm cube will cancel per dm cube. So then if we do the evaluation, we are going to get 309.19 gram per mole. So that is the value of our molar mass. So the next question is to look for the value of x. So to look for the value of x, there is something I want to call our attention to. So mathematics and chemistry, they are very close to each other in some aspects, but they are different in some other aspects. Like in mathematics, if we have dots, so it means multiplication. But in the formula of hydrated compound, like this sodium triisocarbonate 4.xH2O, that dot doesn't mean multiplication, but it is what? It is addition. So that means, since we don't know the value of the x, so the molar mass of our Na2CO3.xH2O will be, so we look for the molar mass of Na2CO3. So that is 106 plus H2O is 18. So the value of x we are looking for, that would be 18x. So that means the molar mass from what? From the formula given to us, the formula mass of the Na2CO3.xH2O will be 106 plus 18. From the calculations we have done in our Roman figure 2, we said the molar mass of our what? Of our Na2CO3.xH2O, the calculated value is 309.19 gram per mole. So if we approximate 19 to 2, then we can have our molar mass to be 106 plus 18x equals to the calculated value in Roman figure 2, which is 309.2 gram. So let's neglect the unit there. It's 309.2. So if we now collect the like times, or we subtract 106 from both sides, so then we are going to have 18x equals to 309.2 minus 106. So that will be 18x equals to 203.2. So we are looking for x. That means we divide 18 from both sides. So by dividing 18 from both sides, our x will be 11.28. Now you need to take note of this. The value of your x, which is the number of mole of water of crystallization, should be a whole number. So that means you are approximating it to the nearest whole number, which is 11. I will call out the studio line now. So for those of you that to have question, so before we move on, then I also have questions for you as well. So the studio lines are 070 47 00 3969, 070 47 00 3969. The second line is 070 47 00 2969. So again, 070 47 00 2969. So now let's continue with the second question. The second question says 23.4 cm cube of 0.2 mole per dm cube HCl acid required 25 cm cube of impure solution of sodium triisocarbonate 4 containing 5.2 gram in 500 cm cube of solution to react completely. The equation of the reaction is 2HCl plus. Hello?
Hello.
Hello? Welcome to Oxygen FM. So completely, the equation of the reaction is 2HCl plus Na2CO3 gives 2NaCl plus H2O plus CO2. So calculate Roman figure 1 concentration of Na2CO3 in mole per dm cube. Roman figure 2 percentage purity of Na2CO3 in the impure solution. Roman figure 3 determine the mass of an impurity in the impure solution. Now solution, let's look at the solution. Now to calculate the concentration of Na2CO3 in mole per dm cubes, what are the parameters given? From the question, we were given the volume of our acid Va to be 23.4 cm cube, our Vb to be 25 cm cube, our Ca, concentration of the acid, to be 0.20 mole per dm cube. So why the information given about the base, sodium triisocarbonate 4, is 5.2 gram in 500 cm cube, which is impure. Now there is something you need to note. There is a principle regarding this question. So we are talking of acid-base titration. That means acid-base reaction. So the acid will only react with what? With the pure base in Na2CO3. So that means the information given about the Na2CO3, which is 5.2 gram, contains the impurity. So the acid will only react with the pure base. So to get this, we are using our formula CAVA over CBVB equals to Na over Nb. And from the equation of the reaction, the mole ratio of the acid to base is 2:1. So we are looking for the concentration of our base, which is the Cb. So we make it the subject of formula. So by making it the subject of formula, we are going to have Cb equals to 0.200 times 23.4 divided by 2 times 25. So the unit is mole per dm cube. So our final answer will be 0.0936 mole per dm cube. 0.0936 mole per dm cube. Now the second thing is to calculate the percentage purity of Na2CO3 in the impure solution. Now we are going to apply the same method we used in our first question, where we converted the molar concentration to mass concentration. So we have gotten the molar concentration of our pure sodium triisocarbonate 4. So we are now going to convert that molar concentration to mass concentration. So the formula we are using is concentration of sodium triisocarbonate 4 in mole per dm cube equals to concentration of sodium triisocarbonate 4 in gram per dm cube over molar mass of sodium triisocarbonate 4. So the molar mass of sodium triisocarbonate 4 is 106 gram per mole. So if we make the mass concentration as the subject of formula, Then we are going to have concentration of Na2CO3 in gram per dm cube, which is the okay. So equals to 0.0936 times 106. That is the molar concentration times the molar mass. So the value we are going to get is 9.92 gram per dm cube. So that is the value we are going to get. But if we go back to the question, we are going to see that the value given to us, the mass given to us in the question, is in 500 cm cube. So, and we said we measure the concentration in dm cube. So that means we have to convert the 500 cm cube to what? To dm cube. So by doing that, we are going to have 0.5 dm cube. Then we can use mass concentration equals to mass over volume in dm cube. So that means we want to look for the mass concentration of the impure Na2CO3. So we have gotten the mass concentration of the pure to be what? To be 9.92 gram per dm cube. So if we now do that calculation, that will be 5.2 gram over 0.5 dm cube. So by doing that, we are going to get 10.40 gram per dm cube. I will call out the studio line again: 070 47 00 3969, then 070 47 00 2969. So by doing that, then we are to look for the percentage purity. So the mass concentration of the pure is 9.92 divided by the mass concentration of the impure, which is 10.4, times 100%. So we are going to get 95.4%. But the other way we can do it is that we can also do it in this way. So from the information given, since we have gotten our mass concentration to be 9.92 gram per dm cube, so that means we have 9.92 gram in 1 dm cube of the pure rather. Then in 500 cm cube of the impure solution, what will be the mass? So that will be our X. So if you cross multiply, that will be what? That will be 9.92 gram times 500 cm cube divided by 1000 cm cube. So we are going to get 4.96 gram. So that means in the impure 500 cm cube of the sodium triisocarbonate 4 given in the question, the mass that is pure there is 5.96 gram. So we can now say percentage purity equals to mass of the pure substance over mass of the impure substance times 100 over 1. That will be 4.96 divided by 5.20 times 100. So because of our time, so by following that second method, we are going to get the same percentage purity to be what? 95.4%. Now the Roman figure 3 is that they said we should determine the mass of the impurity in the impure solution. Don't forget that everything we are doing is in relation to the what? To the 500 cm cube given in the question. And according to the question, the mass of the impure solution, the mass of the Na2CO3 in the pure solution is 5.20, while the mass we got from our calculation in 500 cm cube is what? Is 4.96 gram. So if we do the subtraction, so we are going to get 0.240 gram. So that means the mass of the impurity in the impure solution of sodium triisocarbonate 4 is 0.240 240 gram. With this, because of the time, we are going to call it a day for now. So I really appreciate each and every one of you, and also the production crew at Oxygen FM 96.9